Hi everyone, my name is Kyle Guzman. So today we're going to be looking at problem 15. We're going to see how to solve a problem with RStudio. In this video, we're going to verify a claim made for allergy medication by looking at confidence intervals. We're also going to be playing around with powers. So without further ado, let's get started. So the manufacturer of a patent in medicine claimed that it was 90% effective in relieving an allergy for a period of 8 hours. In a sample of 200 people who had the allergy, the medicine provided relief for 160 people. Determine whether the manufacturer's claim is legitimate, use 0.01 level of significance, right? Okay, so what's our goal? Our goal is to determine whether the manufacturer's claim is legitimate, right? So what is our manufacturer's claim? Our manufacturer's claim is that the medication is 90% effective, therefore our null hypothesis is going to be pi equals 0.90 or pi equals 90%, right? Intuitively, that means our alternative hypothesis is going to be pi is less than 0.90 or pi is less than 90%, and that's essentially saying that our medication is not as effective as 90%. So how we're going to verify this claim is legitimate, we are going to be using confidence intervals. So with our confidence intervals, we're going to be looking for two things. Our confidence interval should be 99%, should be a 99% confidence interval, and our 99% confidence interval should contain 0.90 within its interval. So why is a confidence interval a, um, a reasonable way to to answer our question, like why to verify that our claim is legitimate? Why is a confidence interval good for that? So essentially, a confidence interval is giving you um, all the plausible values of pi, or all the plausible values of the probability where your proportion, is likely to occur, right? Okay. So confidence interval. This is the line of code um, that we use to get a confidence interval using RStudio. We have three variables. We have observed, we have n, which is the population size, observed, which is our number of successes, and we also have a confidence level, right? And these numbers are just an example. It's not has nothing to do with our case study. So our first step to solving our problem and you know finding a confidence interval is to identify the variables. So this is our case study. We're going to be analyzing this text to find out the variables, the value of the variables that we need, right? So first things first, we're going to look for our population size. That's 200, as you can see. Our observed / number of successes is 160, and our confidence level is 99%. That's the same thing as saying a 0.01 level of significance, right? So we have the values of our variables. Now it's time to input the variables into our line of code. You can see our variables right there to the right, that you can see the line of code that we're going to use to the left. We're simply going to take the values from the right and input it into our line of code. So observe is going to equal 160, and is going to equal 200. Confidence level is going to equal 99. That's our code right there. That right there is our line of code that we're going to enter into RStudio. Step 3 is RStudio. So here's a brief introduction of what you need to be able to do exactly what I'm doing, right? So you have to install R. You're gonna have to install RStudio, which is different from R, right? And you're gonna also have to install the workplace, right? Because this workplace provides functions like this one is can be noticed, right? Oh, there should be an M there, but that function is from that workplace, so you really have to get that. Okay, so when you open up RStudio, this is what you're gonna see. Let's bring up our pointer right there, right here. This is what you're gonna see. This is your console right here. This is where you're gonna write your line of code. Right here, do you see that blue text right there? That is our line of code that we wrote. That black text is the result that we get after writing our code, right? So you write your code, you hit enter. That black text is what's gonna appear. So we're gonna zoom in right there. That blue text is exactly what we just wrote, but there should be an M. I forgot to write that M. But again, that this line of code is exactly what we just wrote. It's exactly, yeah, period. Okay. So right here you can see our 99% confidence interval. It starts at 0.71782. It ends at 0.86743. We wrote it right there, right? So this is a confidence interval that's essentially is at 71.7% to 86.7%, right? So clearly, right here, right, our manufacturer claimed it was 90% effective. That's not true according to our 99% confidence interval, right? This interval does not contain 90%. Therefore, we reject it, right? So this claim is not legitimate, right here. Claim is not legitimate. So now we have part 2 of our problem. We have 2 questions for part 2. So we have to compute the power of the test if alternate hypothesis equals 0.80, and we have to find the probability of a type 2 error, right? And obviously, as you'll see later, in order to get this answer, we need to find this answer. So we're going to start off with number 1. So right here, this is the line of code that you need to find the power using RStudio, right? So we have LOS, which is our level of significance. We have N, which is population size. We have prob1, which is our null hypothesis value. We have alternative, which can be less, higher, And we also have prob2, which is our alternate hypothesis. So right there at the top left, we have the values that we collected from earlier. We're just going to pop it into our line of code, right? The same way we did earlier. So LOS, we want a level of significance of 0.01. We're going to input that. And we have a population of 200, input that. Our prob1 is our null hypothesis, which is 0.90, input that. Alternative is less, right? And we'll get into that later. And prob2 is going to equal 0.80 as given to us by the problem, right? So the reason why we're writing less right here is because the value of prob2 is less than prob1, right? So the value of our alternative hypothesis is less than the value of our null hypothesis, and so that's why we write less. So altogether, right there, that is the line of code that we're entering into RStudio. And just a quick note right there, there should be an M right here. And you'll see it in the screenshots that we're going to see right now. Okay. So, again, you're going to open up RStudio. There's a console right here, right? Then there's your other stuff right there. So, in your console, you're going to write that line of code we just said, except obviously the M. I'm going to zoom in right there, right? So, you want that M right there, right? So, that blue text is what we enter into RStudio. And again, this black text is the result, right? So again, you're gonna write this blue text that we just created. You're gonna hit enter, and this black text will appear, right? And so this alternative right here, that's what we're looking for. That's how we get the power. This value right here is our power, right? Boom, we squared it right there. That is our power. We're gonna rewrite it right there. So our problem number 1 right here is complete, right? So this is our power. Boom, check mark, we finished it, right? So next, we have to find the probability of a type 2 error. Now, to find the type 2 error, we have to look at this equation right here, or this expression, right? So probability of a type 2 error equals 1 minus power, right? So our power is right there, as we saw, as we just calculated with r. So we're just going to do 1 minus our power, and that is our probability of a type 2 error. It's simple as that, right? So let's check mark, we checked it, right? And then this is the probability of a type 2 error. This is the power of the test if alternate hypothesis equals 0.80, right? So obviously, if you change the value of our alternate hypothesis, this power is going to change, right? Okay, so in conclusion, we looked at confidence intervals, we looked at power, and we looked at type 2 error, right? We used RStudio to find our confidence intervals, we used RStudio to find our power, and after we found our power, we just did a simple 1 minus power that we got from RStudio to find our type 2 error. So that's finished. Hopefully it was under 7 minutes. Nope, it was close enough though. Okay.